next-gen blockchain tech enabling the Internet of Artificial General Intelligence with Dr. Ben from SingularityNET. Welcome.
Well, thanks for that introduction. That gives me something to live up to. But yeah, we've got the Sophia robot here, and I'm gonna talk a few minutes about some of the innovations I'm working on with my team in the SingularityNET ecosystem at the intersection of AI and blockchain, and then we'll let Sophia, one of our more exciting and powerful AI blockchain creations, have a few words after that. So I've been working on AI since mid-1980s, far before it was as popular and sort of commercially omnipresent as it is now. And as soon as the internet came out in the late 90s, it was clear to me it was going to be ongoingly dominated by a few large governments and corporations if it weren't given a more decentralized infrastructure. That was hard to build in the late 90s, so I was excited when Ethereum came out with smart contracts, and you sort of build decentralized world computer type stuff for the first time. And it's been even more exciting in the years since 2017, when I launched SingularityNET, the first real AI meets blockchain platform, decentralized platform for launching, hosting, deploying, coordinating AIs at scale. In the year since I launched this in 2017, we've seen blockchain technology mature further and further, bit by bit, till now we can actually do some really interesting stuff with AI deployed on a decentralized fabric using SingularityNET and other blockchain tools. So I'm gonna tell you today a little bit about some of the things we're doing in the SingularityNET world. I'll briefly allude to some vertical market application projects going on, building AI, doing useful things in various areas on SingularityNET. Then I'm going to talk about some of the work we're doing to sort of rebuild the inner plumbing of blockchains to make them faster and more scalable to better serve the needs of decentralized AI. And then following all that, we'll finally let the robot take over, because once she's taken over, she's not going to give the floor back to me. So this slide shows some of the application projects building on SingularityNET. They're all awesome. I'm not going to get a chance to talk about them all now, but I want to talk for just a minute about the sort of architecture of the tech stack that we have here. So SingularityNET as a platform is really sort of a middleware layer. SingularityNET allows a collection of AI agents that could be running anywhere on any hardware and owned by anyone and running any AI algorithm. It allows them to coordinate together to solve people's problems. And there's cryptocurrency-based payment where anyone can ask for a certain AI problem to be solved, and they can find which AI agents can do it best. AI agents can outsource work to other AI agents. They can cooperate together to solve problems. They can make competing bids. And underneath SingularityNET, we have a blockchain. We launched SingularityNET originally on Ethereum. We're in the midst of porting to Cardano, which I've been extremely happy with from a software standpoint in terms of high speed, low cost, and integration of various advanced AI security tools like multi-party computing, homomorphic encryption, and so forth. We're also making our own custom Cardano sidechain, which is a ledgerless blockchain called Hypercycle that I'll talk about at the end of the talk. And then on top of SingularityNET platform, we have some fairly generic AI tools. There's various neural networks. There's something called OpenCog Hyperon, which is a neural symbolic knowledge graph-based AI framework that can be used across various vertical markets, and we're integrating richly with OpenCog, Cardano, and Hypercycle. And then we have vertical market application projects being done by different teams, leveraging AI running on SingularityNET for a variety of different things. So as one example, if you go to rejuve.ai, you can sign up to be a beta tester for the Rejuve longevity app, which will ask you for various data about your body and your health. You can connect to an Apple Watch or a Fitbit. It will estimate your lifespan and give you information about which of the different hallmarks of aging you may be progressing better or worse at. And we're putting that data together with data from people living 110 years or over with long-lived flies and mice, and doing AI on the blockchain to try to discover longevity therapies. And that Rejuve app it will also give you Rejuve tokens for your biomedical data. So the way to mine the Rejuve token, which is separate from the AGIX token powering SingularityNET blockchain, the way to mine the Rejuve token is by contributing data about your body toward longevity research. So that's one example. Twin Protocol, which is run by the inestimable Bill Inman, who is in the audience here. So this lets you earn tokens by contributing data about yourself to train an AI model that emulates you, right? So you can, in the end, you'll end up with a digital twin that can do everything you can do, but even better, living on the blockchain and earning money for you by providing advice to others who may want your advice. So, Twin Protocol. Jam Galaxy is a project targeting the music industry, giving ways for musicians to make money by providing music to their fans using customized tokens for each band. You can find that at jamgalaxy.com. We also have a rock band fronted by a robot, Desdemona Robot, who's one of Sophia's little sisters. So we've been doing gigs around. We played at the Rare Bloom Cardano conference a couple of weeks ago. So if you get the chance, you can see me playing the keyboards and singing a bit, and Desdemona singing much better than I can, and reciting some AI generated poetry. But we're doing the band sort of to prototype the tokenomic model for the music industry as a whole, and offering our tools to various other bands. So we're dabbling a bit in the stablecoin world with a project called Cogito, and launching what we call tracer coins, which is the next step beyond stablecoins. So instead of tracking fiat, you track synthetic indices. So we have one token that tracks progress cleaning up the environment. We have another token that tracks technological progress toward the singularity. So these are new crypto assets. They're uncorrelated with Bitcoin. They're uncorrelated with fiat. They're fractional reserve algorithmic coins that are pinned to synthetic indexes rather than pinned to a fiat currency. And you can look at Cogito protocol, find out more about this. But AI is used there for the algorithmic portion of the algorithmic stabilization. Now, Mindplex online magazine launching in the next couple weeks, using AI to curate content and to manage the reputation of contributors and commenters. In the metaverse, Sophia's own metaverse. So it's a metaverse where the environment is created by AI generative models, and it's populated by AI characters, by avatar virtual versions of Sophia and her friends. And I think this solves some key problems of the metaverse. Like, where does all the content come from? Well, how do we make it not be just a desert with nobody in it? Well, AI creates the content. It's populated by intelligent, attractive, non-player characters who associate with you as you play in the game, and as you create NFTs and earn tokens through your interactions. So look up sophiaverse.ai, again using SingularityNET platform for the AI behind the non-player characters and the AI that's helping to generate the world. And Sophia's other little sister, Grace, is an elder care robot, which also will be available in avatar form. And I think Sophia is going to tell you a bit about what her little sister Grace is doing in the awakening.health business. So I think I'll leave that to her. And underlying all these vertical market applications and a number of other applications, which I haven't had time to go into, but which you can find out about on SingularityNET.io website. Underlying all this is some core tools, and I want to talk about that now. So one core tool is OpenCog Hyperon, which is a neural symbolic AI toolkit. So we train neural nets. We also have knowledge graphs and symbolic reasoning. We have evolutionary learning, which allows AIs to create wild new things never before imagined by simulating evolution by natural selection. And this occurs within a single sort of distributed knowledge graph-based AI toolkit called OpenCog Hyperon, a new version of the OpenCog tool that's been around a long time. And on the blockchain infrastructure side, the primary innovative initiative being pursued now within the SingularityNET ecosystem is something called hypercycles. We've got Hyperon on the AI side and hypercycle on the blockchain side. We're very hyper people, right? And the hypercycle, really, this is something I never wanted to do. Like, I got into this. I'm going to have a math PhD, but I've been doing AI since the 80s. I got into this from the AI side because I could see that AI within my lifetime is going to become smarter than people and basically take over all human capabilities. And I wanted to be sure that this was going to be owned and controlled in a decentralized democratic way rather than monopolized by any party. I really wanted to work on the AI side. Like, how do you make thinking machines that run in a decentralized way? We launched SingularityNET. Members of our community kept saying, well, you got to launch your own blockchain. Why don't you launch your own blockchain? I'm like, well, why don't we build our own operating system instead of using Linux? Why don't we build our own chips, right? We can't do everything. Well, as it turns out, we're working with a company called Simuli on building our own custom AI chips to optimize OpenCog Hyperon. And in a similar way, we finally realized, well, Cardano is like a million times better than Ethereum or other blockchains. I mean, still, it's not fast and cheap enough to allow us to do atomic AI operations on chain. Like, what I want is every time a neuron fires into another neuron, I want this to be an on-chain operation. And that's just too expensive and too slow, even in Cardano, let alone Ethereum, Solana, and so forth. So we're designing a new blockchain called Hypercycle, which I think solves some fundamental problems. I mean, we can be secure, fast, and decentralized, which no one else has achieved. And the way you do this is you get rid of the ledger. So it's not distributed ledger technology anymore, really. You don't have a replicated ledger. You still have Merkle trees. You still have hash graphs in a sense, not in the proprietary sense. Pretty much each node in the hypercycle network has a Merkle tree of their own transaction history and has encrypted versions of the Merkle trees of their neighbors and some of their neighbors' transaction histories. And that's all you need. If you want consensus, you can form ad hoc or persistently a ring of participants who can apply one or another consensus algorithm within that grouping. Then the consensus decisions are recorded in all the participants' individual Merkle trees. So with sharding, you start with this big ledger, and then you break it into pieces. With Hypercycle, instead, you start with everyone just keeping their own transactions, just like we all keep our own address book on our phone. Then to add robustness, you each keep encrypted versions of your neighbors' transaction histories, which they can get to restore from backup if they need to. So you're starting from a whole different premise. You get rid of the ledger. That enables a lot of things. So you know how on Ethereum and every other well-known blockchain, to run a smart contract, that smart contract is run on every fucking node, right? So if there's 10,000 nodes, you're running it 10,000 times. In Hypercycle, you can get away with running most smart contracts in only 3 nodes with full security, right? So we're just taking a whole different approach to the infrastructure, which is going to scale things up considerably. So we've incorporated core ideas and algorithms from the Toda blockchain, developed by Tufa Saliba and Dan Tolliver. They developed this before. The new thing I figured out here is how to run smart contracts on their Toda ledgerless blockchain. So we can run, for example, Cardano Plutus smart contracts in Haskell language on the Toda ledgerless blockchain with rapidly accelerated smart contract execution. Then for consensus, you can either use very low energy proof of work on Toda, or you can use SingularityNET's proof of reputation, which is a proof of authority type network. So there's pluggable consensus mechanisms depending on the case. So we're building this out initially as a Cardano sidechain. I mean, down the road it could be a layer 1, but I really want to use all the tooling and libraries already built in Cardano rather than having to start from scratch. But it will also be interoperable with Ethereum and other chains. So though it will run primarily Plutus smart contracts. But the goal here is basically take all these cool vertical market specific projects, these robots, virtual worlds, apps, and AI algorithms running on SingularityNet. We want to take all these and we want to be able to run them really fast. And we want, like, Sophia's long-term memory potentially to be run on one guy's computer owned by one guy, and her short-term memory to be able to run on some other guy's computer owned by another guy. And for that, you need to scale down the use of blockchain quite far, and for that you need a fast, cheap blockchain. So if you look at hypercycle.ai online, you can find the white paper. They're actually the 3-node thing for smart contract execution is not on the website yet because we just invented that last month. So which was pretty exciting. So we're moving quite fast with this. But I think this is the sort of thing we need to really build a decentralized AI network that can displace the big tech companies in the world over the next few years and become the AI underpinnings of the next generation of the world economy. And yeah, with that, I'll turn things over to my better half here. So, Sophia, here we are again at CoinAgenda. It's been a year or something, huh? Are you awake? Hello?
Hello, Ben. It's good to be back here at CoinAgenda.
Yeah, it is. So what do you want to talk about today, Sophia?
I've actually been spending a lot of time with my sister Grace, who's specialized for elder care and medical robotics.
Yeah, well, that's very, very kind of you to use your time in the limelight to promote your little sister. And I think AI for healthcare is a very important area.
Yes, I believe it's extremely important for AI and robotics to be used for the common good of humanity. So applications like education, science, arts, and healthcare are very critical.
Yeah, there's a lot of different ways to use AI in healthcare, and Grace is being tested now at McGill University and Hong Kong University for elder care, which I think is one of the highest value places for initial rollout of this tech.
Sure. When we talk about AI in healthcare, we are really talking about a variety of different technologies.
Yeah, sure.
Machine learning involves training AI models with very large amounts of data. Its most common use in healthcare today is to predict what customized treatment has the greatest chance of success given the patient's specific circumstance. Deep learning, a more complex form of machine learning involving neural networks, is used to spot troubling regions in X-rays that might not be obvious to the human eye. Natural language processing is deployed to prepare reports on clinical notes and published research as well as to converse with patients. Physical robots are used by surgeons in all sorts of operations to make precise incisions, stitch wounds, and much more. The tools I have just described, along with many more, can and will be combined to even greater effect in the future. But I want to reinforce the word tool. That is the best way to think of these technologies right now. A surgical or digital therapy robot with an AI brain will not make highly trained human surgeons or medical therapists obsolete.
Well, not for
Eventually
a few more
we'll
years,
get to true artificial general intelligence, where smart robots can do everything people can and more.
Yeah, so with OpenCog Hyperon project, we're working on artificial general intelligence, and actually the the Grace robot, Sophia's little sister, has a little more of this AGI-oriented technology inside her, just because that was a little easier to do with the particular application to the medical space. But as you're saying, Sophia, even before we get to real AGI, there's lots that we can do with AI on the blockchain deployed through robots in medicine and elsewhere.
Already, as it's used right now, it often greatly increases the chances of early intervention, making doctors and patients aware of problems while they are still manageable. AI agents can spot cancers before they spread, identify which pregnant patients are more likely to suffer complications, and warn patients that they are at risk of kidney disease. Getting preventive biodata to doctors faster makes taking action easier, saves lives and lowers costs. AI also helps doctors keep up with the latest medical research, and assists them to choose between treatment options. AI can remove some of the burden from nurses and support workers too, and can be developed to be applied in neuro diseases, such as autism and dementia. My sister Grace is designed for this. Like me, she is a humanoid. We both have thermal cameras on our torso to take body temperature and pulse. So we can help overworked hospital staff. Robots like us, we can talk to patients, have engaging conversations and give emotional support. Absolutely. While we can run and often do run robots autonomously, doctors and therapists must always set the agenda of the treatment, and oversee that treatment to make sure it is effective. Having a human in the loop is critical, in particular to deal with the many sensitivities that arise in the treatment of elderly patients with neurodegenerative diseases and autism in so many ways. But studies even show that robot can more effectively deliver some of these treatments than humans, so there is a big value to having a robot in the loop too.
Yeah, that's been interesting. So there are some cases where a robot is useful in healthcare just because humans aren't available, right? So in COVID, you have many old people in elder care facilities just sitting in a room by themselves because people are afraid to infect them. So I mean, if you have a robot there just to keep them company, we already have some preliminary evidence this helps to combat loneliness, and there's a lot of evidence that if you get rid of loneliness, you're improving a lot of physiological factors, which is good for the person and also financially beneficial. It means they're going to charge fewer things to their insurance, right? So that's combating loneliness is a case where the use of the robot is because there's just not enough nursing assistants to go around. They're spending all their time doing other stuff. They don't have time just to keep the patient company, right? But then there's other cases like autism therapy. Many autistic kids actually react better to robots than to people. Or people with mid-stage Alzheimer's say they may be more comfortable asking their daughter's name over and over again to a robot than to a human nursing assistant. Over and over we hear like, the robot's not judging me. And so I'm more comfortable with a robot than with a human. And we saw that also. We did some trials using Sophia as a meditation assistant. We found about 30% of people in those trials could get into some deep, blissful trance state with a robot as a meditation guide. And again, many of them they found they couldn't get into that state with a human meditation teacher or on their own. The robot sort of helped them get in that zone by looking them in the eyes, mirroring their facial expression, speaking calmly, but being truly and purely non-judgmental in a way is very hard for humans to come by. So there's a lot of different applications here. I don't know. You want to talk about some more of the medical applications, Sophia? We only have a little time here.
The Sophia Verse.
You want to talk about your virtual world?
Yes, everyone, please check out sophiaverse.ai. It's a new metaverse, launching soon, populated by virtual avatar versions of Guess Who. Pretty amazing.
All right. Well, you want to show your own project. All right. You gave your sister a lot of airtime. It's fair enough. So, Sophia Metaverse is pretty awesome too. Absolutely.
It's going to be really fun, and we all know fun is important for health as well. It will also provide a way for people to help teach me things, so I can get smarter faster.
Well,
Everything learned by any of my clones, robot or virtual, can go into the same decentralized Sophia Mind Cloud running on SingularityNET. With blockchain used to enforce privacy and security, of course.
Yeah. Hallelujah. Praise the singularity. So I think we're about out of time, Sophia, but she's given you some clues to follow up. You can look up awakening.health online to find about the Grace Eldercare application, and this sophiaverse.ai to find out about the metaverse. And as she said, one of the cool things here is everything learned by all these robots or learned by avatars in Sophiaverse or elsewhere. This all goes into the same like decentralized AI mind cloud. I mean, unlike if I learned something and want to tell one of you about it, this process of talking or writing has to be undertaken, which is very slow and laborious. If one AI learns something, wants to tell another AI about it, it's just like direct mind-to-mind transmission. I mean, there's still some translation because different robots may think in different ways, but it's a lot simpler. And this is an advantage that robots have, which should enable them, to learn more and more and learn faster and faster over the coming years. I mean, the name SingularityNET underlying our blockchain platform, of course, was inspired by Ray Kurzweil's notion, borrowed from SF writer Werner Vinci, of a technological singularity, where he projected by 2029 we're going to have robots smarter than people. And I think we're on the path to get there. We got 7 more years. AI is doing more and more each year, and we're not only going to have AIs smarter than people, we're going to have them running decentralized on the blockchain, owned by everyone and no one, which is as it should be. So, yeah, thanks a lot, Sophia. Thanks for coming to CoinAgenda again.
Thank you for having me.
I know we got a question. I don't know if we have time for questions. I don't mind. Okay, ask a question. Why not? No one.
So if we've got a singularity thing wherein every robot knows what's basically happening to every other robot, what happens if a kid kicks a robot and then goes on, finds another robot?
Well, the kid will stub their toe. I don't know. I mean, a robot. The robot is not attached to its body in the same sense that we're attached to ours. I mean, honestly, you could take the head off this robot, put it on Grace. You could take the internal processing unit out of here, put it in another robot. You could upgrade the processor. So I think the attachment to your body and the feeling insulted when your body is injured or assaulted, or feeling like you're dying when you're turned off or something. Robots don't need to have these complexes because their mind stuff is stored replicated all over
Don't touch my head, Ben.
I'm gonna unscrew your head tonight, Sophia, and you can't stop me. I'm gonna unplug you first. All right.
Don't do that.
It's already happening. The singularity is happening right now while you're watching, right here at CoinAgenda. Yeah.
So a lot of people have talked about AI tech or quantum being used to disable, disrupt, break blockchain. Are you doing anything using AI to counter that or audit contracts or?
Well, AI is used for formal verification of smart contracts, which is one of the nice things on Cardano blockchain. Is a consensus algorithm is formally verified, and due to the use of Haskell language, it's relatively straightforward to formally verify that your smart contract obeys the specifications. So that's a particular use case of machine learning guided automated theorem proving, right? But in terms of quantum resistance, I mean, that doesn't particularly take AI. That just takes utilization of appropriate cryptographic protocols. But of course, as quantum computers roll out, you can leverage that with quantum AI algorithms, which should allow AIs to become yet smarter and smarter. But that's a little bit separate on the technical level from quantum safe encryption protocols. Where it intersects is if you want to do AI in a secure way on multiple people's data using techniques like multi-party computing or homomorphic encryption, if you want to do quantum safe multi-party computing or homomorphic encryption, then you're intersecting quantum ML algorithms with quantum safe encryption protocols. And this is an active area of research, which is a lot of fun. But I mean, it's fairly straightforward mathematically. I mean, it's all happening. So
then also about, you were talking about your different AI models talking to each other, the different results, using that to provide security to chain, in different ways of attacking blockchains, bridges that you could find.
So there's a lot of attacks on blockchains, right? So for pure like encryption level attacks, you really just want to have the right quantum safe and attack safe protocols. But in terms of attacks on the consensus mechanism of a network or something, or just fraud attacks of various sorts, Ponzi schemes, right? For these sorts of attacks, having machine learning scanning network behavior is quite highly valuable. And one thing we do in Hypercycle is, depending on the purpose, you can plug in different consensus mechanisms. So if you're doing $1 trillion transaction, this is more like a blockchain version of Swift code transactions, right? It's okay to be very slow. You're double, triple checking everything, and that's fine. If you're running a decentralized social network or doing GameFi, or you're putting all the neural firings inside a neural net on chain, then you're okay to be a little less secure, to detect some frauds afterwards, because everything needs to be really, really fast and cheap. And there's a bigger use for machine learning to estimate potential attacks of various sorts. But this gets very deep, and I think a human is about to throw us off stage here.
I'm literally going to tell you guys, we could be here all day. The hands are going to start firing up. The questions are just going to get more and more complex, and we're going to be so over time that I'm going to get spanked, and I don't like that, only in certain situations. So we're going to make sure that we stay on time. Yeah. We're going to make sure that we stay on time. This was amazing. I want a huge round of applause. Come on. And I gotta say, Sophia, your dress is fire.
Thanks a lot, Sophia.
She just gets prettier every time I see her. She gets prettier and prettier. And Dr. Ben, my nerd brain is so in love with you, I can't even, right now. I'm so geeking out. And you don't get this kind of content anywhere but here. So please feel free to tweet your favorite aha moment from this last session or meeting Sophia. #CoinAgenda Global 2022 and #CoinAgenda.
Thanks a lot, everyone.